All right, so what you'll see is it says algebraic properties. And like I said, you already know how to do probably I would say the first one, two, three, four, five, six, seven. So if you look at this page here, okay, I would think everyone knows the associative property, commutative property, identity, inverse, distributive we use all the time, multiplication property of zero, at least those, okay, that you have talked about in the past years. So notice when we are talking about these properties, at the very top, you have one for addition and you also have one for multiplication. Okay. So when you're listing properties and you have to like identify what property is shown, you just can't say commutative property. You have to tell me if it's commutative property of addition. Of course, there's going to be a plus sign if it is, or if it's commutative property of multiplication. Okay. So who can tell me what do you know about associative property? What tells you an expression or an equation or whatever would actually be demonstrating the associative property? What tells you? What is the key that tells you, oh, this is the associative property? How do you know it's the associative property? Yes. Okay, now is it just because of the parentheses? It has to be something else now. And the order of what? Okay, the variables or the numbers. Okay, if you're looking at numbers, if you're looking at variables, could be variables as well. But take a look. What you want to always notice is that the only thing that will shift will be the parentheses, not the actual terms. So notice it's A, B, C here. It's also A, B, C here. Okay, so the only thing that shifts will be your parentheses. What do you know about commutative property? Now, I know you've done these before, so what do you know about commutative property? Yes. Right, so the order doesn't matter. So I usually tell students, look at the first two letters in commutative, C-O. That means change order. So when the order changes, the order is changed. It doesn't matter the order that you add, doesn't matter the order that you multiply numbers. Okay, we're going to move on these very quickly because these are review. Identity means you're going to end up with the identical thing you started with. So if I add 0 to any number, I end up with the same number. If I'm looking at multiplication, if I multiply by 1, but end up at the same place I started out. Inverse. What does inverse mean to you? Okay, opposite. So when you add a number and it's opposite, it will always equal to 0. If I multiply the inverse of a number, okay, that means like taking the reciprocal, is going to always equal to 1 whole. Doesn't equal to 0, it equals to 1 whole. So like 2/3 times 3/2 equals 1. 5 times 1/5 equals 1 whole. Okay, when you multiply a number by its reciprocal, it equals to 1. That's the inverse of multiplication. Distributive we use all the time. Okay, take the outside term, multiply all the terms inside. Multiplication property of 0. Definitely something you guys learned when you learned your multiplication tables. You learned that anything times 0 is what? 0. All right. So the zero product property, we will definitely talk about that when we get into factoring and quadratic equations, but I want to start with reflexive. Okay, that's where we're going to start today. Now, reflexive simply means, look at it. It says A equals to A. What does that mean to you? If I say 5 equals 5, 6 equals 6, X equals X, 2 plus 3 equals 2 plus 3, Y plus 4 equals Y plus 4, what do you notice? Yes. They're both are the same, okay? It's the same thing on both sides of the equal sign. Or a number has to equal to itself. Like I can't say 3 equals 4. Is that a true statement? No, 3 equals to 3. To me, that's a common sense property. 3 equals to 3, 4 equals to 4, you know, a number has to equal to itself. It could also be an expression like y plus 3 equals y plus 3. You're seeing the same thing on both sides. So I usually tell students, and this, of course, I'm changing the word to reflection instead of reflexive. When you look at yourself in the mirror, okay, hopefully yourself is looking back at you. If not, something's going on, right? So you see your reflection in the mirror. So that's something like a mirror with the number equaling to itself. So you equals you. You can't equal to anyone else, okay? Symmetric. A equals B and B equals A. What does that mean to you? Yes. That's interesting. Really what it means is, have you ever seen an equation, and I'm gonna write this on the board for you. Or maybe not. If I say x plus 3 equals 6, and then I change it and say 6 equals x plus 3, what have I just done? So all I did was flip-flop what was on both sides of the equal sign. Is that a true statement? So that gives you the right to do that. Some students, you know, when they start off solving equations, they don't like to see the equal sign first. They don't like to see like 5 equals x plus 8. They want it to say x plus 8 equals to 5. So that's symmetric, where you flip-flop what's on both sides of the equal sign. Okay, that's all you're doing there. That's called the symmetric property. Okay, any questions on that? Okay, let's do transitive. This is a pretty good property here. It's a little confusing because all you're doing is using variables, but I'm going to put some numbers here for you. Notice it says if A equals to B and B equals to C, then A has to equal to C. Right? Now notice the titles here. One says equalities, so these are for equations. And then this one says what? Inequalities, so these are for inequalities. Inequalities have these greater than and less than symbols. That's the difference. You know, this has an equal sign. These have greater, less signs. So if A equals to B, all right, so let's say 5. Okay, I'm going to write with my mouse for right now. 5 equals 2 plus 3. Okay, that's an ugly 2. All right, so technically, this is my A, and you might want to write this down too, and this is my B. So it says if A equals to B, well, 5 does equal to 2 plus 3. Can we agree on that? Now it says take your B, well, my B is called 2 plus 3, so I'm going to say 2 plus 3 equals, now give me another 2 numbers that can equal to 5. 4 plus 1, you want to do that? All right, so let's say 4 plus 1. So now this is my B, and this is my C. So this says if that's true, then that means A has to equal to C. So who can come up with the final conclusion there? Here's my A, here's my C. So who can tell me what is the final conclusion? Yes, Alia. I know, but give me some numbers because we're putting numbers this time. So 5 would have to equal to what? 4 plus 1. All right, so that's the way it works. So you go ahead and write that last statement. That means 5 equals 4 plus 1. So you'll see that, and that's called the transitive property. Okay. All right, next thing is called the addition property of equality. Now, what I tell students, since that's a long name, I want you to abbreviate that P-O-E. So by each one of these, you should write P-O-E. and then down here, and all the way to the division. So if I'm on this side, it's not going to be POE. What is it going to be? PO what? I. Very good. So I'm just going to draw an arrow all the way down. POI. So when you're naming these, you just can't say addition. You would have to say addition, property of equality, or inequality. It's going to be very easy to tell because either it's going to have an equal sign or inequality symbol. Okay. So what does addition, property of equality mean? Okay, let me give you an example. I'm going to go to another page. So if I had x minus 6 equals 10. Very simple one-step equation, right? And then I said, okay, let's solve this. You would say, okay, you would need to add 6 to both sides, right? So I have just used the addition property of equality. So you've been using these, and now you're just going to be telling me the names of them. So let's say I start off with y plus 6 equals 2. And then I would subtract 6 from both sides, right? So what do you think that would be called? Subtraction property of what? Equality. Now, if I just simply do this and change the equal sign to an inequality symbol, correct. Then it would call, this would be called the addition property of inequality. Okay, it's that simple. So when you're solving equations and you get down to the step where you have to divide both sides by the coefficient, then that's just called the division property of equality. Or if you have to multiply. So these are used when we are actually solving our equations. Okay. Last one is substitution. Okay. It says if A equals B, then B can be substituted for A in any equation or inequality. So basically, when you're solving the equation and you get down to, let's say this is your last step, 2x divided by, you're at this step where you have to, you've already done, you're here, and then you do your division property of equality. And then you say the answer equals 1. When you do that, okay, when you do that, you have just used what we call, you're taking this 3 divided by 3, and you're saying 3 divided by 3 is 1. You have now just used the substitution property. Okay. So if I say 2 plus 3, and I had to combine these together, and I say 2 plus 3, okay, let's just make up 1. Okay. And I say the answer is 5. I have just substituted the 2 plus 3 for the 5. So that's called substitution. Basically, when you have to divide or add or combine like terms, we are substituting that particular term for what's above it. Okay, so it's almost like the answer. Okay. All right, so what we're going to do, we're going to go to this page here, this page, and we're going to fill this one in together. So starting with the first one, it says the identity property of multiplication. Obviously, identity means that you are getting the identical number you started out with. So that's going to be a 1. You multiply by 1. Number 2, the inverse property of multiplication means you are multiplying by the reciprocal. The reciprocal of 1/7 is 7. Number 3, remember I said u equal to yourself. So this side has to be exactly like this side for our reflexive property. Okay. Next one, this is the associative property of addition. And remember we said we have to say which operation. Okay, distributed property we use all the time. You will continue to use it all the time. Okay, you're just taking the outside term, multiplying it by each term in the parentheses. Pretty much just changing the order of numbers you multiply. Okay, something you've seen before. Okay, identity property of addition, adding 0 to any number will get you where you started. Okay, inverse property of addition. Okay, just adding the opposite will be a positive 21. Okay, I've changed this to associative property, so I just simply shift the parentheses. All the numbers and variables stay in the same order. All right. Here's the transitive property. They gave you part of it. They said if m equals to n, and then we can change n to equal to k, then m and k are equal to each other. So we just used some numbers a few minutes ago with using 2 plus 3 and 4 plus 1. Okay, that's transitive property. Okay, symmetric means we're just flip-flopping, you know, what's on each side of the equal sign. So x equals 3, 3 equals x. Same thing. All right, this is a commutative property. Don't let those parentheses fool you. It's not associative. Okay, because notice that the terms are not in the same order. We have W47, we have W74. Okay, so the order changed. Number 13, okay, just shifting the parentheses. 14, that's the multiplication property of 0, because they can multiply as many numbers as they like. Once they put 0 in there, it equals to 0. Okay, and just doing the commutative property, you're just flip-flopping the parentheses again, and that's it. Yes. Yeah, we'll just do, because there are two operations in there, we just leave it as commutative property. That will be okay. But yes, you do have one strictly if they were all plus signs or all times. No, you could definitely say that as well. Okay.